Hello students and welcome to Unit 6 Part 1 Lesson 4. In this lesson you are going to learn a slope formula that can help you calculate slope. So our essential questions today are to review what is slope, to continue to be able to describe what slope means in context to a problem, but to add how we can use the slope formula to find slope. And the slope formula is something that you are going to need to memorize in order to be able to use it. So I need you to work on memorizing what the slope formula says. So let's intro to the slope formula and have somewhat of a review of slope. There is a slope formula that you can use if you know 2 points in order to calculate slope. So this is the time where the slope formula is useful. Now we start with this point because if you think about your method for solving slope in the past, which was in the last lesson, you needed to have a table which had lots of values, or you needed to have a graph that you could use rise over run in order to calculate slope. But now what we're saying is we need less information and we can still come up with a slope, because to use a slope formula all you have to know is 2 ordered pairs in order to calculate slope. Now the slope formula is nice to use because you don't need a graph. All you need are 2 points that would be on the graph. So it saves time in not having to graph the relationship. Now remember, slope compares. That means that it's a ratio. Anytime we hear a comparison of 2 amounts, we know it's going to look like a fraction and compare, in this case, the amount of change in the dependent variable to the amount of change in the independent variable. The y change is on top, the x change is on the bottom. Rise over run in the case of the graph. Now I want you to meet a man that can help you remember the 4 types of slope that you learned in the last lesson. This is called Mr. Slope Guy. This picture, within this picture, you can find all 4 types of slope. Here at his eye and his eyebrow, a line that goes up is positive, so here's one type. A line that goes down is negative, so there's the second type. Here in the middle, a vertical line is undefined, so you see a U connected to it, so this is the third type that you can find in there. And a horizontal line is equal to 0, a 0 slope. So you can see the 4 types, 1, 2, 3, 4 of slope. So this slope guy can help us today review the 4 types of slope. Now let's talk specifically about the slope formula. Remember, slope is a change in y over the change in x. How much the dependent variable changes when the independent variable changes. So here's what the slope formula says. Remember, we have to know 2 points to use the slope formula. So if we know 2 points, a first set of points and a second set of points, and they are on the line, then if you subtract the y values and you subtract the x values, you can get slope. Now notice, this ordered pair doesn't say xy. We labeled it x1, y1, just to indicate that this is our first point. These subscripts do not have any value except to differentiate them as the first point and these ones as the second points. Now, some textbooks and some teachers will write that the slope formula is y2 minus y1 over x2 minus x1. This will make no difference in the problem. So it's only saying that this is the second point and this is the first point. So if you see them reversed, don't be confused. It's still the slope formula. It's just, I believe that this way is easier to remember. Take your first y, subtract your second y, take your first x, subtract your second x. So let's practice using the slope formula. It says, find the slope of a line that contains these 2 points. Now, remember, the slope formula says if you have 2 points, x1, y1, and x2, y2, then slope equals y1 minus y2, subtract the difference between the dependent variables, over x1 minus x2. So our first step is going to be able to label our 2 points, x1, y1, x2, y2. Because then we are going to use substitution into the slope formula to calculate slope. So right now we know that slope equals y1 minus y2 over x1 minus x2. So y1 is the first variable that we know the value of, so we're going to substitute negative 2 for y. So we have negative 2 minus, now we have y2. y2 is 2. Okay, so now we have y1, which is negative 2, minus, because that's part of the formula, y2, which is 2, over x1, which is 4, minus, because that's part of the formula, negative 1. Now, we just did step 2. We substituted x1 and y1 into the slope formula. Now we need to simplify. So I would call step 1 label, step 2 substitute, and step 3 simplify. Now, the first thing that you need to look for when you're simplifying these expressions is if you have minus and negative, you need to rewrite that. Minus a negative is kind of like taking away debt. So you can rewrite it as a plus sign, because how do you take away debt? You pay money. So I'm going to rewrite this with a plus sign since I have minus and negative. So I have negative 2 minus 2 over 4 plus 1. Now, negative 2 minus 2 is negative 4. 4 plus 1 is 5. Negative divided positive is a negative, and 4 over 5 will not reduce, so our slope is negative 4/5. Now, if you graphed these 2 points on a coordinate plane, you could do rise over run, but you would have to go down 4 and over 5 to go between these 2 points. Let's look at another example. So remember, step 1 is going to be that we're going to label our points. So we have 2 points here. We're going to label them x1, y1, and x2, y2. And all that means is this is our first ordered pair, and this is the first x value and the first y value. This is our second order pair, and this is our second x value and our second y value. Now our second step is going to be to substitute. Our slope formula says if we know 2 points, then slope is equal to y1 minus y2 over x1 minus x2. We know the value of all 4 of these variables, so we're going to substitute in. y1 is negative 2, so we're going to write negative 2 minus. Now y2 is negative 2, so we have negative 2. Do you see how I clearly put the minus sign and then I substitute y2, because we don't want to mistake this negative sign with y2 for the minus sign that's built into the slope formula, over x1, which is negative 2, minus 7. Now on to step 3. All we need to do is simplify and we'll get our slope. Now remember, the first thing that we're looking for is, do we have minus and negative, because we want to rewrite that as a plus sign. So we have negative 2 plus 2 over negative 2 minus 7. Now that we've taken care of minus our negative and rewriting it as a plus sign, we can simplify the expression. Negative 2 plus 2 makes 0, and negative 2 minus 7 makes negative 9. Now, in the last lesson, we learned that anytime we have 0 over a number, we know that 0 divided by negative 9 equals 0, so this has a 0 slope, which makes sense because two inputs have the same output, so they're going to lie on the same horizontal line. So our slope is 0. Let's look at one more example using 2 points, and then we'll move on to some other forms of relationships. So let's find the slope of the line that contains 5, negative 7, and 6, negative 4. First step, label x1, y1, x2, y2. Second step, substitute into the slope formula. So we have slope is equal to y1 minus y2 over x1 minus x2. Remember, I want you to memorize this as the slope formula. Now, substitute values. y1 is negative 7, so we have negative 7 minus y2, which is negative 4, over x1, which is 5, minus x2, which is 6. Now, step 3, simplify. We have minus and negative, so we're going to rewrite that as a plus sign. So we have negative 7 plus 4 over 5 minus 6. Negative 7 plus 4 is negative 3. If you owe 7 and you pay 4, then you still owe 3. And 5 minus 6 is negative 1. A negative divided negative is a positive, and 3 divided by 1 is 3. So our slope is positive 3, which still means 3 over 1. And on a graph, we go up 3 over 1, up 3 over 1, and so on. Now, let's look at one more example in this part of the video, and that is what to do if we have a table. Now, this only adds one step to our 3-step process, and that is that we have to find 2 order pairs. Do we have 2 order pairs? Yes, we actually have 4. So we just have to choose any 2 to use. In my opinion, it's easiest to use the ones closest to 0, or the ones that contain whole numbers. Since all of these are whole numbers, I'll choose these 2 lowest values. So we have 0, 1, and 2, 5 as our 2 points in the relationship. I know they're in the relationship because they're part of the table. So I'll label them x1, y1, and x2, y2. Substitute them into the slope formula. y1 is 1 minus y2, which is 5, over x1, which is 0, minus x2, which is 2. 1 minus 5 is negative 4, over 0 minus 2, which is negative 2. Negative divided negative makes a positive, and 4 divided by 2 is 2. So the slope of this relationship is 2. Every time the input goes up 1, the output goes up 2.